Kind of get started, so for helideck systems, you'll always refer to NFPA 418. This is the code for these types of systems, and it'll walk you through everything you need to know about the helidecks. Some brief stuff here. When we get into the foam that's required most of the time is a 3% AFFF mil-spec foam. Must be used on all helideck and helipads, or there are exceptions when the HJ wants something different. So it's a 10-minute duration of foam is required, plus 2-minute foam duration for the hose reels. And you must have a density of at least 0.10 that you achieve across that entire deck. Here's just some formulas how to figure out how much foam you need, so you can figure out what size tank you need as well. For the main foam, and these are all about the same. For the main foam, the test foam, exactly the same. The durations are a little different, is really about the only thing. But your density times the area times the discharge duration times the concentrate times the 1.15 safety factor will give you the gallons of foam for your actual system. Then you have your hose reel foam that you're required 60 GPM per hose reel. You usually have one up there, times the 0.3 foam concentrate, 2-minute duration, and then the 1.15 safety factor. And then you would bring in your test foam, which is the density times the area times the duration again, which is 1 minute, and then it's the 0.3 or 0.03 foam concentration times the 1.15 safety factor. You'd add all three of those together, that'll give you your total foam required. Most tanks, bladder tanks, will hold about 5 to 10% more than they're rated for. So if it's a 200-gallon tank, it'd be 220 gallons. So this is just kind of a sample helideck that we laid out. This one's 55 by 55. We've had some other helidecks that we could have really covered with one 360-degree nozzle in the middle. The deck was only a 40-foot round helideck. The problem with that is, there's always that chance that the helicopter would land on that one nozzle, block it. So we've always kind of designed the helideck systems to make sure we have at least 2 nozzles to cover this. So if that ever happens, then the other one will pretty much make up for it. So this certain helideck required 4 nozzles, 2 360-degree nozzles there in the middle, and then 2 90-degree nozzles on the outside of the gutter system. And we achieved a 0.1236 density with these 4 nozzles. Once you lay out the pipe and do your hydraulic calculations to size all your piping, including the riser, then you would kind of get in more detail of what valves you're using and all that. Anytime we use a grate nozzle or a helideck nozzle, we'll use the pilot pressure regulating flow control valve. What this does for you is all these systems will have a dead man aboard on them. And so you want to be able to shut that valve down immediately if there's a false activation or whatever it may be, but you always have that function with these valves. And we're going to play a video to kind of go through how this valve works. So you'll be able to see that and how fast it closes if somebody was to hit the dead man aboard.
When the Model J1 pilot pressure regulating valve is in the set position, the priming water is in the priming chamber, holding the clapper down on the seat to hold the water coming back into the inlet. The priming water stops at the emergency release, as well as it stops at the solenoid valve. The solenoid valve is normally closed. Once we energize the solenoid valve open, the priming water is going to travel down through the trimming into the C2 pilot regulating valve. Once the valve opens, water is going to flow into the sensing line from the outlet of the J1 flow control valve. Once the water flows into the sensing line, the priming chamber is only going to be allowed to open so far. We have now energized the solenoid valve open. The water is flowing into the C2 pilot regulator valve, out into the sensing line, and the priming chamber has only been allowed to open so far. Once we turn the switch off, this is going to de-energize the solenoid, and with the help of the spring in the priming chamber, it is going to close the valve and shut off the supply. And just like that, the valve shuts down.
So this is riser diagrams that we have, depending on what type of system you use. I mean, this is, of course, for the helideck type system, but we have these riser diagrams for about any kind of foam system you could possibly need, hopefully. Splatter tanks, atmospheric tanks with different valves, all that, deluge, flow control, wet systems, what have you. So we can always send you this whole riser diagram, and you can just paste it right on your drawings and be done, really. It's pretty simplified. It's a whole list of all the materials that are included in that riser that you'll need to order. And then you've already got your foam quantity that you need and what size tank that'll be. But again, don't hesitate to ask for these riser diagrams, depending on what kind of system you're doing. So this is a little bit better picture of the helideck nozzle. This would be the center nozzle, the 360 degree. These will, the receiver box will get mounted into the rebar before they pour the deck itself. And then once the deck is poured, you'll come back in and drop in your grate that'll have the nozzle in it, along with the 12-inch piece of galvanized pipe that'll drop down through the receiver box there, tie into your groove 90 below, and you're set and ready to go. You'll also see on this receiver box that all the rain and snow will drop in around that, the nozzle area there, drop into the receiver box. Then there's an outlet for a drain. That drain is usually tied into the gutter system on these helidecks. So if there is fuel that gets in there, it'll go to the same containment tank as well. But everything will drain down to a containment tank. So, and then when you get into the bigger helidecks, like that 55 by 55 we saw earlier, you would use just the nozzle itself that sits on the outside the gutter system and sprays into the deck, onto the deck there. So this is where you'd use the 180 degree or 90 degree nozzles. So it sprays on there pretty well. This is about a 25-foot spray inward. It covers that deck very well. I'll show you some pictures of that here in a little bit as well. These are the only nozzles for helideck that are listed and approved. So UL listed and FM approved. The same nozzles are listed and approved for hangers as well as the grate nozzle. These nozzles can also be installed on ship decks and are listed and approved for the foam system on those as well. The coverage area is about a 25-foot radius, 50-foot diameter circle. So pretty good spray pattern, as you'll see here in a minute. So this is just some pictures of from start to finish here. It's an actual discharge on a helideck on a casino in the Philippines. So this was actually the grate nozzle back then, and now again it's the same nozzle, just in a different grate that becomes the helideck nozzle. So initial discharge down there in the lower right-hand corner, and then about 10 seconds into it, it instantly covers the deck, and to get full coverage, about 32 seconds. So it's pretty quick and covers everything. It's a phenomenal nozzle. There's nothing that compares to it right now. The spray itself, the pattern never gets higher than 18 inches off the deck itself. So that keeps it away from the wind and that. So these pictures are pictures of one of our competitors' nozzles. So as you can see, over time, it takes about 2.5 minutes to cover the majority of the helideck. Still hasn't covered it all. That's the lower right-hand corner again. But you can see how the wind catches the spray of the foam, kind of pushes it all over the place, more so onto the roof of the building than on the helideck. But it's a quite lengthy process to get this whole deck covered with these nozzles. And that's a problem with a lot of the helideck nozzles that are out there. Their spray patterns are so high, 12 to 15 feet in the air, that the wind just catches them and does whatever. So this is a picture of an aircraft carrier with same type of nozzles. Again, the wind catches this spray pattern because it's about 8 to 9 feet in the air, and a lot of it goes overboard, as you can see from this picture. So we're looking at trying to retrofit some of the aircraft carriers with our helideck nozzle as well. Just to kind of break down, you can use monitors on these helidecks, but just keep in mind that monitors take at least 100 psi and use a lot of water to make them work. So our competitors' nozzles use approximately the same pressure and water as ours, but it takes a lot more of them. Usually on a 55 by 55 deck like that we saw earlier, it would probably take 12 of the competitors' nozzles to cover that. And again, it would be 2.5 to 3 minutes to get the foam to the middle of it. Both these have very high spray patterns, so again, the wind takes it and blows it to wherever it's blowing. So, you know, the Viking helideck nozzles are the only ones that have a very low spray pattern, again, 18 inches, and require only 40 psi to work. So, pretty low starting pressure there. Kind of a quick overview here. So what's the radius of the spray pattern for a 360-degree nozzle? It's 25 feet. So just and these are just some kind of quick notes, so everybody kind of walks away with some quick knowledge of these. What are the three spray patterns of the helideck nozzle? 360 degree, usually in the middle, 180 and 90 degrees, usually on the outside of the gutter system there. And then what is the NFPA code that covers helidecks, helipads? NFPA 418. And then what kind of 3% AFFF foam must be used on helidecks foam systems per 418, and that would be the mil-spec foam.
What is the starting GPM and PSI on the 360-degree nozzle?
Okay, so that's 40 PSI at 147 GPM.
Could you explain, does the nozzle pop up and spin around, or does it remain flat?
Yeah, there's absolutely no moving parts on these nozzles. They don't spin, they don't pop up. They just spray out. They sit maybe a 1/16 of an inch higher than the grate itself. Will not cause any kind of tripping hazard, anything like that, but no moving parts whatsoever. But we get a great spray or coverage out of these nozzles.
Following up on that question, is the value documented on the C2 pressure?
It is, yes. If you go to the data sheet on the J1 pilot pressure regulating valve and the trim, it will talk about the 20 PSI loss on that data sheet.
Can you use the helideck nozzle for other applications, like a warehouse or any other facility?
We can actually. We're working on 2 flammable combustible storage rooms projects where they happen to have a trench in these rooms, and we are looking at using the grate nozzle or the helideck nozzle in those trenches. We can, depending on the quantity of nozzles that we need to put in a trench, we can adjust that grate to a different width, so it'll fit into an existing trench.
What type of systems are commonly used to protect helidecks, like wet, deluge, pre-action, manual shutoff?
For helidecks, it's going to be usually always the pilot pressure regulating valves, just because they can be shut down with a dead man aboard.
Someone asks, what kind of cleanup or drainage is required for these? Interesting question.
So every helideck will have a gutter system. depending on who built the helideck, to whether it has slopes just one direction to one gutter or whether it has a gutter system all the way around it. We've seen them both ways. That gutter system will then go to a containment tank to capture all the foam water. As far as cleanup goes, you can just spray down whatever residual foam is left to that gutter system as well and squeegee it, and you're done and ready to go.
Can you use this nozzle for fuel tender facilities as well, where fueling trucks load up for airplanes as an example?
You could, as long as there's a trench system there, yes.
Thanks again, Bob, and thanks to everyone in attendance. We'll hope you'll join us in the future. Have a great day.